All right, so there's 3 pieces to this graph. What do I know about the first piece of the graph because of the stuff that I've taught you from this? What do I know about this equation? What kind of graph is that going to be? A line. How do I know that? Because it's just x to the first power. What do I know about this second piece? What type of graph is that going to be? Parabola, because it's x squared. And what do I know about this final piece? It's also going to be a what? A line. So don't write this down. I'm just showing you. I know that it's going to look something like a line, then a parabola, and a line. Maybe it's connected together. Maybe it's a line, a parabola not connected, and then a line. And again, if it was like this, do you see how it's equal to the -6? So this would be my ending point. So it would be a colored in -6. Do you see this is my ending point -2 and it's equal to? So this would be my colored in. What does that mean about my starting point for my parabola? Because it's not equal to. This one would have to be the open circle. What do I know about this end of the parabola? Why is he saying open? Because again, where it ends would be not equal to. And then here is equal to. So it would be actually something like this with a closed circle and a closed circle again. Some kind of graph like that. Again, you don't have to draw that because I'm just trying to give you an idea of, okay, this is kind of what I know is going to happen here. Yes or no? Now, here's the way we graph this. Do you see this right here? This is the criteria that has to meet in order to use this equation. Meaning, you're only going to use this equation when x is between -6 and -2. You're going to use this equation when x is between -2 and 1. And finally, you're going to use this one when x is between 1 and 3. What does that mean my domain can only be for this graph? -6 is the lowest x will be, and 3 is the highest it will be. So if I was drawing this out, just hang with me. I know I'm going to go 3, 4, 5, 6, 1, 2, 3. I know my graph is going to start and end here. Does that make sense? Yes or no? Where is the first one? Because I have now there's how many pieces are going to be between those two lines? There's going to be 3 different pieces, yes? Where is the first piece going to start at and where is it going to end at? It's going to start at -6. And where's it going to end at? So I'm going to kind of do this again just to help myself out. This is not really part of the graph as far as this is not the graph. This is just to help guide me. So I'm saying it's going to start at -6 and the first piece is going to end at -2. So I need the piece of the graph between there. Now this equation right here is a line, correct? So technically, a line would be like this, and it would go on forever in both directions. But when I put this criteria in here, it's like I'm cutting this part off. And because of this criteria, I'm cutting this part off, and the only part I really need is this section. Does that kind of make sense as far as what we're going to do? Now, I don't know if that's where the section is yet because I haven't graphed it properly. I'm just giving you the overall idea. Yes or no? So let's graph it properly. How do we graph? I'm going to show you 2 ways because one's to review something that's old. How the heck do I graph 2x plus 5? How do I graph that? You could do an x and y chart, but I want to graph it in slope-intercept form. I want to go and review how to graph something that's in slope-intercept.
Wouldn't you use 5 equal to 2 over 1?
Perfect. What is 5? Garrett, you need to come on. It's going to be bad for you. You can't do that. Not in this class. What is positive 5? It's my y-intercept. That means that I'm going to go on my y-axis. 1, 2, 3, 4, 5. And then, what is my 2? What is this right here? It is my slope, but I need it as a rise over run. So like you said, She said I need it as 2 over 1. Now, here's the only problem with that. If I go up 2 and I go over 1 and I go up 2 more and I go over 1, am I getting closer to the part that I need? You get that the part is supposed to be between the red lines, right? And my slope keeps carrying me the opposite direction. So if you remember, I told you there's always 2 ways to write a slope. What's another way that I could write this 2 over 1 as the same exact slope, but just change it, and it actually allows me to move a different direction? Someone said negative 2 over 1. Is that correct? No. Negative 2 over negative 1, because what happens when you have a negative and negative? It's still positive, and now watch what happens. Now I'm moving down 1, 2, and to the right, or to the left 1. Did I get closer to the area I need to be in now? So I'm going to continue using this slope. Does that make sense why it's so important to know those 2 slopes? So I'm going to keep going down 1, 2, and over 1, down 2, 1, 2, over 1, down 1, 2, over 1, down 2, over 1, and finally down 2, over 1. It's not perfect because my graph, especially on this, is not very good. So I'm only going to draw in the section that is between the red. What am I going to do to these actually 2 ordered pairs? This one that I did here and the Y. What am I actually going to do to them? What did I do to them? Hello, what did I do to them? Why did I erase them? Because it's not within the criteria that it needed to be. I only wanted the piece in between it. So the piece that was outside of it, notice I what? Hello? Am I talking to myself? What did I do to it? I erased it. It's gone. Does this line continue going on forever this way? Does it normally? Yes. Why is it not going on forever right now? Because why? They told me in the question, I only want the piece that's between here and here. That's what made it to where it's not necessarily an infinite. It cut off because I'm only using a piece. What piece? The piece between -6 and -2. If I just asked you to graph this right here, does everybody understand it would go on infinitely? You see the difference here? Nick, are you with me? Questions on that? I went over that because that helps you review how to graph something in slope-intercept form. Now, there's a second way I could have got this same exact graph. In geometry, how many points do you need in order to make a line? You only need 2 points. Between 2 points, there's only 1 line. Does that make sense? Well, right here, what did I tell you this was? Oh my gosh, I'm gonna freak out and this computer's been screwing up all day. What is this? Where the graph starts, and this is where that graph, yes? Isn't that my input of where it starts? And isn't this my output of where it starts? So what I could have done, and it's gonna get me the same ordered pairs, is I actually could have used -6 as my input, and -2 as my input, and got the ordered pair for only those 2 points, the starting point and the ending point. And then once I got those 2 ordered pairs, I can just draw a line between them, and I would have the same exact graph that I did doing the other way. It's the same exact graph, it's just a different way of getting it. Do you follow me? Do you follow me, yes or no? You sure? Then ask a question. What's your question? If I have X, what do I have to do to find the output? You got to plug the number in to this equation. And then, so I'm plugging in -6. So I'm going to go negative 6 times 2, which is negative 12, and then negative 12 plus 5, which is negative 7. There's how I got my output. I'm going to plug in negative 2 in for x, so right here I'm going to put a negative 2 in. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. Now, I shouldn't really have to graph this, because those should be the same exact ones I already got. And if I look at it, negative 6, negative 7. Well, 1, 2, 3, 4, 5, 6. Isn't this negative 6? This right here. And then 1, 2, 3, 4, 5, 6, 7. Isn't that where I put the ordered pair last time? Do you see how that ordered pair is already there? Because it should be the same. It's the same graph. I just did it a different way. What else do you notice? What was the other ordered pair I was going to use? No? Do you see that I just put negative 6, negative 7 on there? What's the other ordered pair? Oh, negative 2, 1 right here. If I go on there, look, negative 2, 1 is the other ordered pair that was already there. And all I have to do is connect those two. So 2 ways to graph a line. What's the first way? Do the slope-intercept form, but the only thing about the slope-intercept form is sometimes you're going to have a piece of the graph that falls out of the section that you want, and you're going to have to erase it. That's the first way. Slope-intercept form, that was taught to you in Algebra 1. What was the second way that I did? I plugged in where it starts, and then I also plugged where it ends in, and I got x and I got a y. I plug in, I got a y, and then I plot those 2 points on there and then draw a line between them. Garrett, you gotta get up, dude. You gotta fight. If you need to stand up by your desk for a minute. Seriously. So you don't fall asleep. I don't care. Stand up and write your notes. You can stand in the back. But you gotta, I know why you're tired. But we gotta fight it. That will help you. Now, I have graphed the first section that was in red. Now I'm about to attack the second section, which I'm going to do in green. What did we say the second section is going to be? Okay, can I just do what I did for the one above it, the line? Can I just get 2 points to graph a parabola? No. What do I need in the parabola? What is the most important point for a parabola? The vertex. So I need the vertex. And then, if I get the vertex and then the 2 ending points, that's good enough for me. Do you get what I just said that? So let's attack the vertex. What is the vertex of this question? Well, this is where I taught you the other day. What is this going to do? Do you guys remember me telling you this is going to move it down 7? Well, if that moves it down 7, where's my vertex normally? 0, 0. If I move that down 7, where's my vertex going to be now? So does everyone understand why I know my vertex is 0, negative 7? Oh, by the way, I do need to talk about this. I did get lucky. But because this is equal to, and because this is equal to, what did I do to both those ordered pairs down here on the red section? They colored them in. If that was not equal to, one of those, or whichever one was not equal to, would have been an open circle. You'll see that in our next example. Do you follow me? So there's my vertex for the parabola. Now, what would be the 2 other points that I want to plug in to figure out? Negative 2, where it starts. That's how I know I'm using negative 2. And what's the other one I want to go to? And so those are the 2 things I'm going to plug into the equation and see what my output is. So this is the x. That means I plug that in right here. Negative 2 squared is, that's why we need to know order of operations. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 7 is 1. And yes, you have to be able to plug in, and I am trying to get you to be able to plug in your brain. This class, you're going to plug in a lot. You can't write it down every single time and take forever. 1. Plug in 1. 1 squared is 1. 1 times 2 is 2. 2 minus 7 is. And so I'm going to also plot negative 2, 1 on there. Well, what happens when I go to negative 2, 1? That was where the last graph left off. So I know these graphs are going to connect there. Remember, I said it doesn't always happen. And then 1, 2. Oh my gosh, this thing has been screwing up so much. It's really irritating. You can. 1, 2, 3, 4, 5, 6, 7. I have some up there in the bottom shelf. And then it said it went to negative 5, right? So 1, 2, 3, 4, 5, boom. So I know the parabola piece looks like this. And what is this one? But it started where the other one was already closed, so I leave it closed. Now, what do I know about this one, though? It's not equal to, so what do I need to do for right now? Now, what can happen to that open circle? If the other one starts there, it can close it in, but it might not, so we leave it open for right now. Does that make sense? All right. Which way, because I have 2 ways, I have a personal favorite. Which way did you guys like for graphing the linear? Because I'm now going to move on to my third one. I think plugging in is the easiest way. So I'm going to make an X and Y chart, and since it's a line, why do I recognize it's a line? Because X is only to the first power, so I recognize, okay, I can do this way. I can just plug a what in? Nope, careful. I can plug a 1 in. That would be one of my inputs. And what's the other one I can plug in? 1 and 3. I use these 2 numbers. That's where it's going to start, and that's where it's going to end. I plug a 1 in. Negative 4 minus 1 equals a negative 5. Negative 4 minus 3, negative 7. So my order pair is 1, negative 5. What do I notice about that? The minus was already there. One, negative 5. What do I notice about that? And so I'm going to color it in, and then 3, negative 7 is right here, and I'm just going to draw a line between those 2 points. So really, this is my graph. I'll do it in purple. My final graph would look like this. Here, here, there. This red part and the black part aren't really part of it. I just drew those in to say this is this piece, this is this piece, this is this piece. It's really just a guide for me. They're not part of the graph. Does that make sense? Yes? Try another one. Once I do this, I'm not going to take this long for this next part. I'm going to go faster on this one. Because really, I know it took me 20 minutes because I'm explaining it to you for the first time. But really, once you get these down, they should take like 3 minutes when you do it on your own. It should not take that long. So here we go. F of x equals 4x plus 11 negative 10 absolute value or less than or equal to x less than negative 2 x squared minus 1 negative 2 all the way to 2, and finally x plus 1 from 2 all the way to 10. All right, what do I know this graph is going to kind of look like? a line. But with my line, it's going to be a closed circle to a what? Does everyone see how I know that? Has to do with these right here. If it's equal to, it's a closed circle. If it's not equal to, it's an open circle. To a what? The first part's a line. Then what's the second part? And I don't know if they're connected or not necessarily, but I know it's to a parabola, with the parabola being a closed circle here and a closed circle there. To a what? And I don't know if the line is up or down or anything like that, but I know it's an open circle line to a closed circle. Are you starting to see that? Now again, it could be maybe, again, connected where it goes like this and like that and then like that could happen. And these get closed in because they end up where the other one started, or it could end up looking like the thing I first drew. But I know it's going to be a line to a parabola to a line. I already kind of get that in my head. I'm already kind of, this is called number sense. It's like, all right, I got a plan. Here's what this is going to kind of look like. What are my x values going to be? What's the smallest x is going to be for the entire graph? -10. What's the biggest the x is going to be for the entire graph? 10. It's going to start here, but it's eventually going to end here. Now, how many pieces are there going to be? 3. Are you seeing how I kind of understand all this stuff before I go into it? When you graph it. Once we make the graph, if this one ends at 1, 1, and this one starts at 5, 4, you won't be able to look at it and tell whether they're going to be connected or not. It's not until we actually do it that we're going to realize if it's a Frankenstein that's connected or if it's not. So here's why I thought about that. Oh my gosh. Did y'all see that? I move this thing all the way down and it jumps all the way back up to the top. That means, what do I need to mark off from my x coordinates? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it always going to be whatever you went to the left, you're going to go to the right? No. Just happened in this case that that's what they did. You with me? What type of graph is the first one? So I'm going to extend this page because I know this one goes down actually pretty far. What does that mean I'm going to do? What's 2 ways I could graph this first one since it's a line? Okay, we could plug in, and what would be our 2 values we would plug in? We would plug in -10 and, because we care where it starts and where it, and since it's a line, I only need 2 points. So I get the starting point, the ending point, connect them, and I've got it graphed. Now, what's another way I could do it? I could say, hey, this is my y-intercept, this is my slope, and I could do that. I think that's longer, but it still works. Again, the reason I show it to you is because I want to try to, the more you see it, the more you remember it. And later on, we're going to need how to do it the old school way. We won't be able to just plug in every time. Does this make sense? So let's go ahead and do the X and Y chart. I would plug in a -10, and you said we could plug in a -2. I need to hurry up. -10 times 4 is -40, plus 11 is -29. -2 times 4 is -8. -8 plus 11 is 3. Notice that's math. That's not, that's not algebra 2. -29, so -10, -29. So I'm just going to mark that on here because we don't have time. So -10, and my computer can't handle it. -10, -29. And then the other point was -2, 3. -2, 3. And then all I have to do is try to connect these. It's not going to be very good because I can't see it. It's not terrible. I did actually a pretty good job. Connect those two. Yes or no? Now we're going to go on to the middle one. So this is in red. Now I'm going to do the next one in green. I know it starts at -2 and goes to +2, but what's the problem with it? It's a what? Which means I need how many points for it? 3. I need the vertex and the... All right, let's get the vertex. Does this thing move left or right? Looking at the way that it, remember the stuff that we did where if it's inside the parentheses that moves it left and right opposite way? That's the stuff I taught you yesterday. We're still using that. This doesn't move it left and right anywhere. So it's 0. And it is down 1. So it's 0, -1. Because all I do is move the vertex down 1. And then the other things I would plug in would be a -2 and a +2. If you plug a -2, -2 squared, I'm right here plugging in. -2 squared is 4. 4 minus 1 is 3. 2 squared is 4. 4 minus 1 is 3. So it's -2, 3. -2, 3. What do you notice about that? It connects where the other one ended, yes? And the other one is 2, 3. So my U shape in the middle look like this. And then finally, we're going to finish this off with the third piece in blue, which is a line again. So I'm going to just do the endpoints for it fairly quickly. X and Y, what am I going to put in? 2 and 10. I plug a 2 in, 2 plus 1 is 3. 10 plus 1 is 11. So I go 2, 3. Oh, look, that's where it ended. So the other one's picking up right where the other one ended. And I'm going all the way to 10, 11. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 10. It looks something like that. I will see X and Y charts all over your paper. Last thing, a second type of question that they can do. They can say, hey, graph this. That's one thing that they can do. Please pay attention to this. The other thing they can do is not ask you to graph it. They can ask you, hey, I want you to find f at -5. This is the x, correct? Yes? Does -5 work in piece 1, piece 2, or piece 3? Where is -5 good for? Well, is -5 between -10 and -2? So what does that mean I'm going to plug the -5 into? The top equation. And you would plug it in. -5 times 4 is -20. -20 plus 11 would be -9. If I said f at 0, would you plug it into the first equation? No, why not? 0 doesn't fall between -10 and -2. Where does 0 fall between? This one and this one. So you would plug it into the second equation, and 0 squared is 0. 0 minus 1 would be a -1. When they give you the f at 5, they are giving you the x value. You have to find the output, which means you got to plug it in. You have to figure out which equation to plug it into. Do I plug it into 1, 2, or 3? And that depends on which x they give you. What does 5 satisfy? Does it satisfy this one, or this one? The third one, because it's between 2 and 10. And so I plug in 5. 5 plus 1 is 6. Are you understanding the two different types of questions they can ask you from this? You will have homework on this tonight to practice it. Okay? Please, please, please work at this. Maybe this helped out some of the stuff in the previous. Okay? If that did, then go back and try some of that old homework. You got a whole weekend. Work, work, work. The more you put in right now, it's going to be better. YouTube, you can research. You can put in YouTube the name of the chapter and search some videos on it. You've got to put in work. Don't rely on me. I will help you, but I'm only here for so long. Okay? Makes sense?
I understood a lot more the second time.
Yes, that happens.
First time I never
Online, are we good?